Hello, good morning. Good morning. We'll start with a lesson. Today, as I have discussed in the last class, we have completed the error detection method and as well as the humming code. I think you all executed the humming code and you got an output. Any doubts in execution of the humming code, you can message me or you can even call me and you can ask me. That is a one which we had discussed. Coming to the next, reliable transmission. So once the receiver has detected the frame is having an error, so that will be discarded. Once it has been discarded, the other host should send, means the sender should send the same frame, retransmission of that same frame must be done. Then how the sender comes to know that it has to retransmit that particular frame, and how the receiver will intimate the sender that that particular frame has been discarded. So this is a reliable transmission which we are going to discuss today, and this is also an important topic. In other words, we'll call it as a sliding window protocol. Now, I'll share the screen. We'll start with a lesson. Back here. Yeah. Now, coming to the reliable transmission. Now, CRC is used to detect the errors. As I told you, this was an efficient one where the disadvantages is very less here comparative to the parity bit checking, and another one is a humming code which can be done only for on a single bits. Even though humming code does the correction, it will be done for only a single bit. So, as I told you in a last class, that the reliable transmission fundamental techniques will be the acknowledgement and timeouts. So, based on these two things, the transmission, reliable transmission will be done. How? The sender will send a frame and it will wait for some particular time for acknowledgement from a receiver. So after sending an frame, the sender will be in it will start its time. So it will be keep on waiting. Some fixed time will be there. So coming to the receiver side, receiver will receive that frame after accumulating all the zeros and ones. It will makes the framing, starting and ending point, how it will detect. Later on, it will go with an error detection algorithms. So once it is error is there, the frame will be discarded and no acknowledgement will be sent. Here, the sender will be keep on waiting. So what time it should wait? So there will be some fixed time. Assume that, for example, I'll tell you 1 minute. So after 1 minute, the retransmission of the same frame will be done from the sender side. Once assume if frame doesn't have an error, what receiver will do, whatever the frame it has been came with a header, so that data part the receiver will take, the header whatever will be there, that will be sent back to the sender by the receiver as an acknowledgement. Once the header will come back to the sender will assumes that the frame has been gone correctly. So within this should be done within 1 minute. It's an example what I told you. It should be done within 1 minute. So then the sender will send a next frame. Coming to the next in detail of this particular thing. So how an acknowledgement? Now, an acknowledgement is a small control frame that a protocol sends back to its peer saying that it has received the earlier frame. I repeat, so it is an acknowledgement receiver will send to the sender, and it is a small means small frame, small control frame which will be sent back from DDL, means data link layer protocol, as an intimation. Usually a control frame is a frame with header only, no data will be there, as I told you. The receipt of an acknowledgement indicates to the sender of the original frame that its frame was successfully delivered. Once the header of that frame will come back from a receiver, then sender will think that yes, the frame has been reached correctly without any errors, and it will starts sending the next frame. Coming to the next concept, if the sender does not receive an acknowledgement after a responsible amount of time, as I told you, so it will wait for the sender will start its timer and it will wait for an acknowledgement. Assume for some particular amount of time, if the header is not came, the acknowledgement is not came, so the particular original frame will be retransmitted. The waiting of for some particular amount of a time, we'll call it as a timeout. So what is the timeout here? That sender will start the timer when it sends in a frame. So it will wait for particular time. Within that time, if acknowledgement comes, the frame reached correctly. Otherwise, if time goes ahead, so retransmission of a original frame will be sent. That is called as a timeout. The general strategy of using acknowledgements and timeouts to implement the reliable delivery is sometimes called, note down this, sometimes called automatic repeat request ARQ method. Underline this. This is very, very important concept in a computer networks. As a computer network designer, every designer or every person, network professional, should know this particular concept. Without this, today there is no internet at all. Keep in your mind. That means when a peer-to-peer communication is going on, that is when a host-to-host communication is going on, automatic repeat request is very much important. That is a reliable transmission method which uses acknowledgements and timeouts is very much important. Coming to the next thing. Now we will go to the first basic type of a protocol in a sliding window protocols, that is stop and await protocol. It's a basic concept which has been used. The idea of the stop and wait protocol is a straightforward. What is that straightforward? After transmitting one frame, the sender waits for an acknowledgement before transmitting the next frame. That's why we'll call it as a stop and wait. So the transmission of the frame will be done by the sender. After sending a frame, the sender will wait for an acknowledgement from the receiver. After getting an acknowledgement, then only it will send. If the acknowledgement does not arrive after a certain period of a time, the sender timeout will occur and it retransmits the original frame. Whatever a previous frame is there, it will be retransmitted. This is called as a stop and wait protocol. Very simple. I'm telling, the sender will send a frame, waits for an acknowledgement. If acknowledgement comes within a time period, that means the header will come back within a time period, the sender will send a next frame. So other cases, the sender will send in a frame, it will wait for an acknowledgement, means acknowledgement not received within a particular time. So then what happens? The sender will retransmit the original. Here, lot of cases is there. We have to think on a particular cases in general. For example, I will tell you some cases like this. What is the cases here? The frame has been sent. Okay, assume that the acknowledgement also has been sent from the receiver side. The acknowledgement gets discarded in between or drops in between due to some network issues. Here frame reached correctly at a receiver. Receiver also send an acknowledgement, but acknowledgement in between somewhere in a network, it has dropped. Now what sender will do? Sender will wait as usual. It will wait according to its time. Within a timeout, it's not coming. So retransmission of the frame has been done again. Now what happens at a receiver side again? Again the duplicate, redundant frame of that same frame it will go. Now here the confusion starts. So coming in depth of this particular sequences, you can see here the 4 sequences are there, which is very important while writing in an exam. Now see, the first sequence is a normal sequence. That is, a frame will be sent in figure A. I am talking about a figure A. Everyone observe figure A. The sender will send a frame here. It has been come here. So within a timeout, observe, this is a timeout period. Within a timeout, the receiver will send an acknowledgement. So the frame has reached correctly. Then the sender will send a next frame. Come to the case number 2, that is B here. The sender is sending in a frame. The sender is sending in a frame. The frame has dropped in between somewhere. The frame has dropped in between somewhere, not reached the receiver. So if it doesn't reach the receiver, receiver will never send an acknowledgement. Correct? No. So what happens here? The timeout will occur at a sender side. For a sender, the frame has been sent already, so it will start its timer. But receiver never receives a frame, so it never sends acknowledgement. Here timeout will occur. Once a timeout is occurred, the same frame will be sent back again to the receiver. Now again the receiver will receive and it will give the acknowledgement within a timeout. Now this is a second case. Come to the third case, that is C. What I told you. That is, assume the sender has sent a frame. Yes, receiver receives the frame and the frame is correct, no errors. Acknowledgement has been sent, but acknowledgement has dropped in between. Once the acknowledgement has dropped in between somewhere, what timeout will occur at a sender side? The sender will retransmit the same frame again. And now it receives, the duplicate frame has received here. Now acknowledgement will be sent again, the same acknowledgement within a time. Now it receives. Now coming to the D case here, this is also, you observe this D case. What is this D case here? The sender will send a frame and the acknowledgement will be sent by the receiver. Due to some congestion in a network or due to some congestion or network problem, delay will occur and acknowledgement will come late, that is after the timeout. Here sender, it will start its timer. Once the timeout will occur, automatically the retransmission of the frame will be sent when acknowledgement not received still. So timeout is occurred. So automatically what happens, according to the technology or instructions, the sender will retransmit the frame again and the acknowledgement will be received. So in this way, these things will work. Now here, some disadvantages is there in a different cases that we are going to discuss in this particular protocol. If the acknowledgement is lost or delayed in arriving, the sender, observe, the sender times out and retransmits the original frame, but the receiver will think that it is a next frame since it was correctly received and acknowledged the first frame. As a result, duplicate copies of frames will be delivered. This is important. I told in a last case, if the acknowledgement is lost or delayed in arriving, both in the C and the D case, what happens this? So the sender will retransmit the same frame, but here the redundancy of the frames, duplicate of the frames will be there. That will make the eating up of a buffer in a receiver side or the making up of the delay. Due to that, the problem will arise. How to solve this particular problem? So this problem can be solved here. How to solve this particular problem? What according to me is, if if receiver comes to know that this frame is already sent, so automatically it must discard that frame. It shouldn't store in a buffer or a memory. If it discards that, then a memory eating up or a buffer eating up will be reduced, where the usage will be of the memory will be very fast and the network performance will be good. So to solve this particular problem, we'll go for, we will use 1-bit sequence number sliding window protocol. Note down now, we'll use 1-bit sequence number sliding window protocol, which will work on stop and wait thing. Now, 1-bit sequence number means for every frame which has been sent, the sequence number will be given. The sequence number will not exceed 1. Always it will be 0 or 1, 0 or 1, 0 or 1. For example, how 0th frame is sent, the next frame to be sent is 1. Now automatically receiver knows here. Once 0th frame received means the next expected frame is 1. Automatically when sender and receiver uses 1-bit sequence numbered sliding window protocol or stop and wait protocol, here they know that once 0th frame received, the next frame should be received is 1. Assume that again 0th frame itself will come, automatically receiver we can discard that frame. So this is a simple technique which is going to be adapted. Now you see here, when the sender retransmits the frame 0, the receiver can determine that it is seeking a second copy of the frame 0 rather than the first copy of frame 1, and therefore can ignore it. The receiver still acknowledges it in the case the first acknowledgement was lost. Now this is very simple. In a previous case, we are not giving any sequence number to the frames, but here now we are giving a sequence numbers, and receiver comes to know that which is my next frame will come. Once 0th frame came, assume 0 frame acknowledgement has received, but acknowledgement files in between. Now again, at the sender side, what happens? Timeout will occur. The sender will resend the 0th frame again. Now, here the expected frame, here the receiver side, the expected frame is 1, but 0 frame will come. Then it thinks that something has happened at a sender side. What it thinks? Oh, okay, something has happened. It will resend the acknowledgement of the 0th frame, and it will discard that frame. Why? Because already frame is there. So it will discard that particular frame. Now, sender will receive that acknowledgement. He will send a frame 1. Now it's a method, means here that C and D case has been solved easily in a 1-bit sequence number. You see now how it will be solved. Now coming to here, in a stop and wait 1-bit sequence, how it will works. The sender will send a frame 0, receiver will send acknowledgement of the 0th frame, and the receiver is expecting frame 1 here. Once 0th frame has received and sent an acknowledgement, the next frame expected by a receiver is frame 1. Frame 1 has been sent and it's correct. The acknowledgement will be sent back. Now the receiver will expect next 0. Why? Because here only 0 and 1 sequence number frames will be there. The next bit must be arrived is 0. The frame will expect, means receiver will expect that. And acknowledgement will be sent if it received correctly. Now coming to the next slide. Now the sender has only one outstanding frame on the link at a time. Now what is the problem here? In one sequence bits. One sequence bits is the problem we have solved C and D, but now another problem arises. That is, at a time only one frame can be sent, either from a sender and receiver will send an acknowledgement to that particular thing. Assume your channel capacity or a medium capacity, your bandwidth is very good, and your frame uses only a part of it. Then the utilization of the capacity of your link will not be there up to the mark. Correct? No? Why? Because assume that the same frames 4 or 5 you can send at a time, and your receiver can receive this, but you are sending only one frame. Another 3 or 4 frames bandwidth, it will be wasted. Now to solve this particular problem, we will go to the another type of a protocol. Now observe here, what is the disadvantage in one sequence method is, the sender has only one outstanding frame on the link at a time. We know that. This may be far below the link's capacity. If link's capacity, it will be very less, you are not utilizing. To use the link fully, means if you want to use your bandwidth fully, then only you will feel that the internet is fast. Then sender should transmit many frames before having to wait for an acknowledgement. So the sender, what is the capacity of that particular link? That many frames he will send, and you must wait. Now again doubt arises. Then how the acknowledgements can be sent? This is the problem. Then how the acknowledgements can be done? Either receiver should send each and every one frame's acknowledgement. Either last frame acknowledgement, if it sends, it's okay. Either in between any frame will last, how that particular frame, means assume that 1, 2, 3, 4 has been sent. Assume that 2 as filed. How to identify 2 frame as filed? So again, all these problems will arise when you go to the sending of a bulk frames. Now this will have a step to the different other sliding window protocols that will enter one by one. What is a sliding window protocol here? Here we are going to slide the many frames, more than one frames at a time. That's why the word sliding window protocol. That means we'll keep one window size, we'll make one size, in that size, window size, we'll fill the frames and we'll send the frames at a time. Assume. Now here window size is, you are seeing here. The window size is 3 here, assume. Now all the 3 frames has been sent to the receiver. Receiver is sending all the 3 acknowledgements back and sender is waiting until the timeout, and within a timeout if he receives the acknowledgements of all 3, then he will send the next 4 frames. That means it will be keep on incrementing in a additive method, in a sliding window protocol. It will starts with 1, next to 2, next to 3, next to 4, next to 5. If no errors occurs, 5 acknowledgements will come. Next to 6 acknowledgements will come. 7 acknowledgements will come, like that. Somewhere occurs any congestion is there, again it will come back to 2, means 1, again 2, 3, like that, again it will keep on incrementing. So this is one particular method of a sliding window protocol, that is sending all the frames, receiving acknowledgement for all the frames, then it will send a set of frames with additive increment of the frames at a sender side. Now coming to the next slide. Now observe here, very important concepts you have to observe, and these variables plays a very much important role in a sliding window protocols. Sender assigns a sequence number denoted as a sequence number to each frame. This is very much important. Observe now, CQNUM is a one field name which is added in a header of that particular frame. Now here afterwards, each and every frame will have a sequence number. Not 0 and 1. It will have from 0 to maximum numbers or n numbers. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that, the sequence numbers will keep on going. Assume it can grow infinitely large. Infinitely large. Now, sender maintains 3 variables. Note down everyone. Note down this. This is very much important. If you doesn't know about these variables, you can't understand a sliding window protocol. Now, sending window size is one particular variable. What is this? How many frames it can send? What is the size of a window? SWS is one variable which will gives the upper bound on the number of outstanding unacknowledged frames that the sender can transmit. That means still now we doesn't received any acknowledgements. That many means what sending window size means 4 it can send, means 4 is the SWS value. In that 1, 2, 3, 4 will be there. Now observe here, the last acknowledgement received. For which frame last acknowledgement has been received? That is called as LAR. Now last frame sent, which is the last frame it has been sent? LFS. Which is the last frame it has been sent. LAR means which is the last acknowledgement it has been received. Don't think that both should be same. Don't think that both should be same. For example, assume that I will tell you like this. 1, 2, 3 frames has been sent. Once 1, 2, 3 frames has been sent, the next frames to be sent is 4, 5, 6. Assume just for a sake, I'll tell you. 4, 5, 6. Now 4, 5, 6 also it will send. Here the last frame it has been sent is 6. Now assume one by one the acknowledgement will keep on coming. Now I will tell either way like this. From a sender side, 1, 2, 3 has been reached. First 1 it will send, 2, 3. 1, 2, 3 has been sent. Now receiver what it should do, receiver side 1, 2, 3 acknowledgement should come. Right? Here the last frame frame sent is 3. Sender side. So LFS is 3. Now window size, whatever is there, it has been sent is 1, 2, 3. That is SWS. What is a LAR? Assume the receiver will send first acknowledgement 1. One acknowledgement received here. So now LAR is 1. Next 2 is received. Assume 2 is 2 will be the next LAR. Assume 3 frame is not correct or discarded here. Just for a sec, I'll tell you. Now, here what happens, the receiver will not send acknowledgement for 3, only it has sent for 1 and 2. Now, here it's waiting for a third acknowledgement, timeout will occur. Now it will compare which frame to be sent in 1, 2, 3 back. This is important. Which frame should be sent in 1, 2, 3, which frame should be retransmitted. Here, now the LFS plays a very much important, and last acknowledgement received variable plays a very much important. First it will see last acknowledgement received. Here last acknowledgement received is 3, but last frame sent is, last acknowledgement received is 2, but last frame sent is 3. Timeout occurred. That means that the LFS and LAR are different. So if LFS, LAR same, then it will send 4, 5, 6. But here, in this case, what I am telling, the third frame is discarded here. Because of that reason, the last acknowledgement received is 2. So automatically, the last frame sent 3, whatever it will be there, it will retransmit. Now it will send 3, 4, 5. Are you getting now? This is very much important. 3, 4, 5 it will send. In this way, this variables plays a very much important role in a sender side. Coming to the receiver side, how receivers will make a note of it. Now assume the formula here, what I told. Now, so the sender also maintains the following invariant. Always it should be like this. LFS, the last frame sent minus the last acknowledgement received should be always less than or equal to SWS. This should be there. That is 1, 2, 3 frames means it has been sent. Assume, for example, second frame it has received, last frame it has been sent is 3, and last acknowledgement received is 2. 3 minus 2 is 1. 1 is less than or equal to always this window size. That is 3. True. So always this should be maintained. So in this way, in a sender side, the sliding window will be maintained. When an acknowledgement arrives, observe here. Now what I told, it will be there here. When an acknowledgement arrives, the sender moves LAR to right, thereby allowing a sender to transmit another frame. That is, the sender moves LAR to right. Once acknowledgement comes, last acknowledgement received. 1, 2, 3 frame it will send. 1 acknowledgement received, then it will goes to 2. Then 2 acknowledgement received, then 3, like that. Also, the sender associates a timer with each frame it transmits. It retransmits the frame if the timer expires before the acknowledgement is received. I told in a case of 3. The last acknowledgement received is 2. The last frame sent is 3. Timeout occurs. That means third acknowledgement not came. So automatically retransmits of 3 will be done. Note that the sender has to be willing to buffer up the SWS frames. Means always it will keep on buffering up the particular SWS frames. Then the additive, it will keep on increasing starting from a small amount of frames. So this is a nature of a sliding window protocol, SWS, at a sender side. Now come to receiver side. Now this is very important here, receivers. Receiver side, receiver will have RWS. That means 1, 2, 3 frame here like this. 1, 2, 3 frame has been sent. It has to it must have a capacity to receive 3 frames. For example, best example I'll tell you. For example, I will throw 2 balls to my opponent. He is having 2 hands. He can receive the 2 balls. Assume I will throw 3 balls to my opponent. He doesn't have a 3 hands. So definitely when 3 balls are coming, he can, at that particular time, he can catch only 2 balls. Another ball will be dropped. So the RWS should be matched to that particular thing here. Now coming to the next thing here, the largest acceptable frame. the largest acceptable frame, sequence number from the largest acceptable frame, which frame it has been accepted, last frame received, which frame it's accepting means next frame which has to be come and what frame it has been received, that is called as LFR. Now in detail of this particular lesson will be continued in the next class, and I will tell you what are the different variants in this particular sliding window protocol, and based on these variables how the different types of other sliding window protocols you can take into the consideration, how you can solve the problems, and what are the disadvantages in this particular sliding windows, and how different variations will come like negative acknowledgement, additional acknowledgement, and selective acknowledgement. So piggyback method and all we are going to discuss in coming next class, which is there on Tuesday. Thank you very much for everyone. Monday, please at the lab time you practice summing code program, socket and client program, all the three programs you execute. Any doubts is there, please you call me or you can send that error messages to me. I will send you why that error has been came and how you can solve that particular. Yeah. Now I will stop sharing of this. Yes. Thank you very much. Audio, please.
Thank you, sir. Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Any doubts? Any doubts?
No, sir.
Any doubts? Okay, you follow up the video in YouTube channel. I will upload it once again. If any doubts are there, feel free to call me. Okay.
Yes,
Yes,
sir.
sir.
Good health. Okay. Bye bye. Bye bye bye.
Thank you, sir.